Okay, hello everyone, my name is Mandy. Today I'm going to introduce the topic post-depositional metal enrichment process inside manganese nodules from the North Equatorial Pacific. And before heading to the formal talk, I would like to give a brief introduction of manganese nodules. Manganese nodules are usually found in abyssal plain and seamounts. It contains high percentage of varied metals such as manganese, nickel, copper, iron, aluminum, and cobalt, and some other elements like silicon. And with the rich contents of the metals and abundant yield, mining industry getting emphasized on the development of the manganese nodules. So what actually benefits of the manganese nodules bring? The first one is extraction of the manganese nodules will meet the rising need for the specific metals like lithium and nickel. This material are used for the smartphone batteries. And the lower battery price will in turn make green energy and electric vehicles more affordable. Okay, after learning the basic knowledge about the manganese nodules and its benefits, we'll now go back to our formal talk. Post-depositional metal enrichment process inside manganese nodules from the North Equatorial Pacific. And the place we're talking today is in the North Equatorial Pacific, and which is founded in the Clarion and Clipperton fracture zone. You can see it's in the middle of the Pacific. And this is one of the nodule massive region. And the map on the right, you can see there are several places, and they are all the nodules massive regions. Like Peru, yep. And the special place of the Clarion and Clipperton fracture zones is because they contain higher concentration and concentration of nickel and copper, manganese and nodules than other places. And today we're going to talk about and this table shows that the fracture zones have the higher nickel and copper than other nodules massive region. And our motivation is to explain why this place has such much accumulation of high concentration of manganese nodules. And we want to figure out the metal uptake mechanism, and in other words, to research the way those metal deposits. And we use three ways to investigate these questions. The first one is X-ray diffraction technique. This technique is used to identify the mineral in the nodules. And another one is electron microprobe, mostly abbreviated to EMP. This can examine the elements and their quantity, the elements' quantity in the nodules. And the last one is the mostly used in the whole research. It's called scanning electron microscopy, SEM. This is used to observe the interior texture of the nodules. And first one, we are going to talk about the observation outcome of the X-ray diffraction. They found that the nodules here is mainly decomposed by the todorokites. And here is the, it's mainly composed by, those elements. And also, decomposed by the zeolites and the clay mineral. And the observation by the electron microprobe, you can see in this figure The y-axis means the contents of the metal. When the peak is higher, the contents go higher. Yeah. And the x-axis from the 0 points is the exterior side of the manganese nodules, and the far side is the core of the manganese nodules. You can see that the first one nickel, and the second one copper, and the third one manganese. You can see that at the exterior parts, those metals has a higher concentration. And also, when you can see closer, oh sorry, my picture is not really clear, but you can see that there is a lot of box in the picture. And we can see that when there is a VOG, the nickel, copper, and manganese concentration have a higher at the broader of those box and voids. And interestingly, iron has a negative correlation with those metals, of those three metals. And our discussion is going to talk about why those metals isn't distributed in evenly way. And the last one, the observation by SEM. Through the SEM, we can see the texture of the manganese nodules and also some components in it. We can see that they are amorphous and colloidal matter. Amorphous means that things that didn't have a specific state. And the organic and biological debris is also found in the manganese nodules. Also, the detrital, altered rock, and mineral fragments and crystallites of austenitic minerals are all found in the manganese nodules. So we can see there is a lot of things that is composed of the manganese nodules. Okay, here comes the discussions. The former, we have mentioned that there is organic matters in the manganese nodules, and the degradation of the manganese and those organic matters will reduce the metal oxides, which means remove the oxygen from those metals. We can see the formula you can find that the oxide iron become soluble iron. And those metal iron turn out to deposits on the manganese nodules. You can see in the step 3. In the step 3, the ions reacted with the manganese oxide and becomes the deposits. And the other discussion is why the equatorial places have much more copper and nickel there, nickel manganese nodules. That is because Equatorial Pacific Ocean is a region of high biological productivity. The organism there is much more abundant there, and the organism will concentrate the trace metals while they live in. And that organic complex also function too. They have strong ability to challenge with certain transition elements, notably like copper, nickel, and zinc. And we can see that sorry, I was lost in the formula. Oh, we can see in the step 4B, the soluble nickel and copper turn out to combine with the divalent manganese oxide, and it becomes the tellurides, the main components of the manganese nodules. Okay, thanks for listening. This is my talk.
I want to know how does the nodule form, like a bowl shape or just a cone?
Can you repeat again?
Okay.
Go to the right. Sorry, coming here.
Okay. I want to know how does the nodules form like a bowl shape?
Oh, I got it. Reynold wants to know how the nodules form like a bowl shape. This is not the, that is an interesting question, but I can tell you now.
Can you back to the result of the EMP?
Oh, EMP. So what do you want to ask?
Next.
Next one.
Next. Yes, here.
Oh, this one.
You say that the iron has a negative correlation with the Nicole and the copper or the magnesium, but at the second square, I don't think the iron has the negative correlation with these three parts.
Okay. Yonghong say that I said Fe showed a negative correlation with other three metals, but the other square didn't show this negative correlation. So how can I explain this? This Hilde crack not only contains of metals, but also like totally voids or organic matter. Can I use Chinese? No. That is so hard to explain because that is whole chemistry to try. Okay. Because in the manganese, those components are all in the amorphous states. Like they are not in a stable state. So they tend to become more stable. So when you see the Hilde crack, that means that places don't have metal. Metal tend to combine with each other.
Could you explain toroidal again?
Repeat. Ryan asks, can I explain the toroidal again? That is a kind of mineral. And what do you want to know about this mineral? Composition. Well, the composition of this mineral is composed by calcium, sodium, magnesium, and manganese, and with some hydrogen.
Have any sea area have this one without the Pacific Ocean?
Can you repeat the questions again?
Have any sea area have this one and without the Pacific Ocean?
Have any sea
area
iron
and sea area?
Sea area. Is there any other sea area have manganese nodule?
Yeah.
Oh, yes. In my formal talk, I have said that manganese nodules can be found in abyssal plain and mountain range and sea mountain. But you can see in these pictures, there is still like Peru basin and Tyson basin, Bay basin. and other places have rich nodules. So there are still other places with nodules. Can you go back to the figure that has 4 different metals? 4 different metals.
EMP.
Yes, EMP. And I want to know, is there any correlation that makes the figure of Nicole and Cooper look similar? Because they are when Nicole has the high data and Cooper has high, and when they are low together.
Explain, repeat.
Okay, Fiona say that can I explain why Nicole and Cooper have the positive correlation, right? Just like when Nicole go high and the Cooper is high too. That is because Nicole and Cooper have the similar characteristic. They are similar metals. So when they combine with the organic compound, they have a more tendency than other metals to combine with them. So so nickel and copper have similar distribution.
You say the property of it will influenced by biological productivity. So in RC, it's also influenced by biological productivity or other reasons like chemical or other reasons.
Can you repeat your questions again?
Sorry. You say the high biological productivities will concentrate trace metals while leaving, and it will lead your it will make your nodules properties different. So in RC, it will also influence nodules properties or not.
So you want to ask, is there any other factor that will affect the nodules content?
In RC.
Oh, I can check later.
You say you use the X-ray, EMP, and SEM to analyze this sample, and as I know, the X-ray and EMP can arrive the seabed in the seas. So, do you have another sampling method, or use the gravity core or another tools to gather samples?
I repeat the questions. You want to ask, do I use other device or instruments to gather the data? I only use three ways, like X-ray refraction and EMP, and the last one is USEM.
X-ray can arrive in the seabed.
Oh, so what do you want to ask?
X-ray cannot arrive to the seabed, and how do you use
So
X-ray to analyze?
they collect the samples to the ground.
This is what my question.
Oh, so sorry about that. Okay, you want to ask because X-ray cannot reach the sea ground. So how do I make it? The way they use is to collect the manganese nodules from the sea to the ground, and they use the EMP to examine the contents of it.
So actually, this
is a little bit difficult, this topic, because it's very chemical and mineralogy, so it's not easy to explain very clearly. And I think Mandy, she has did a quite nice job, because that's the reason why many of you can ask questions, right? But in terms of clarity, here are some comments. So the good thing is she talked about the application of nodules, so you know it's related to our human industry, daily life, etc. And here, her slides have this two-layer structure. You know, you have a background and then you have a white block, and this will restrict your space because, for example, this figure. If I were you, I will make this big, that big. So because you were struggling reading the text here, make it really big, and also the same for this, make it very, very big. I was unable to read this graph, especially this one, all right? And you see this figure has really poor quality. All right, I need to teach you again, many of you. If you want to copy a paper, a figure from the PDF, please make sure you do the first copy first. I don't know how to use this. Where is the copy graph? Anyway, you do the first copy, and you have to enlarge. Well, the original figure is poor. Okay, I see. But this is a general rule. Make sure you enlarge your PDF before you do the copy and paste. All right, I think many of you know that. Okay, and this is too small, so I was unable to see which metal was being talked about. So that's a general weakness of the talk. The graph was too small. Okay, and then and she looked for some supporting table and data. These are all very nice because that will explain the motivation of the study. And regarding the presentation of SAEM figure, I don't know how many of you will have this kind of figure. The general rule is here, she has the figure and text separately presented. However, the best way to present this kind of figure is to print the keywords. For example, if you think this is the so-called amorphous matter, then you print the keywords directly here. And you use an arrow to point to the feature you want to discuss, instead of using this, because when you were presenting this, your text and your figure was two different things, and they are not linked to each other. Okay, and here, regarding the presentation of formula, I will highly suggest that you you type the formula again yourself. And a general, my own habit is if I want to present, you see these are the name of the minerals, I will look for the photos of the mineral from Wikipedia or internet to improve the impression. Otherwise, people have no feeling for these minerals. They are just names, like they are just Latin names of animals, though no meaning to us. So give us images. Okay. And lastly, it would be good you talk about this productivity. It would be great if you can show this image again and then show us an image of the global chlorophyll A distribution. So we have a better idea why you say there is high primary productivity. You can find this kind of image on the internet. Finally, please give us a conclusion. Okay, overall it's a very nice talk, and let's thank Mandy. Next week.